Hello student. So today's class is for ICSE class 9 students. So this is mainly the revision classes for you. So as you all know that in your half yearly exam, mostly the chapters which are going to cover, that is the motion in one dimension, Newton's laws of motion, pressure, upthrust, and the unit of dimension. So these are the five chapters I will do revise today, and maybe few school you are having the the electricity or heat part that I will cover in different class. So today's class I will show you the strategy how we are going to revise these five chapters. So these five chapters, you have to focus on the keywords and you have to practice. Take a white page or and just do the practice in this way. Like the motion chapter, what are the keywords you have? The displacement. Next is the velocity, acceleration, and the force. Okay. So these are all the vector quantities, right? So all these vector quantities is having their definite dimension and they are having a relation. So what is displacement? Displacement means the shortest distance covered between the 2 points in a specific direction. It's a vector quantity. Next is the velocity. Velocity means displacement by time. It's again a vector quantity. Next is the the acceleration. So acceleration means what? Acceleration means change in velocity by time. And what about the force? So force is basically is equal to mass into acceleration. So this is about the equations. Now, so these are all the vector quantities, right? And now next is the graphical relations between the displacement and time and velocity and time. So displacement time you will be taking s in the y-axis, time t in the x-axis. So this st graph, if this is a straight line parallel to the time axis, that means object at rest. Object at rest. S is not getting changed with respect to time, right? So object will be at rest. So these are the distance, and for different time these are not getting changes. These are not getting changes. Okay. So this is an object at rest. Object at rest. Next is that object is having an uniform velocity. Object is having an uniform velocity. This straight line, if the ST graph is a straight line, it's presenting the uniform velocity, right? So velocity V is the change in displacement by change in time, right? Change in displacement by change in time. Okay. So this straight line presenting the uniform velocity for ST graph, right? Now next is so this is a practice class, right? So I'm just going like that. So if this is a parabolic graph, ST graph parabolic, this is presenting the accelerating motions. So AS is proportional to T square. The displacement varying with time in a exponential manner, right? So this is presenting the accelerating graph for AS and T. AS is y-axis displacement and x-axis is time, right? So this is about the ST graphs. Next is the velocity time graph, right? Velocity time graph what? So in the y-axis you will be taking the velocity and the x-axis you will be taking time. First of all, draw the straight line. So velocity time graph straight line. This is presenting the velocity is not getting changed or uniform velocity. So this distance are same. So y-axis are same. Time is getting 1, 2, 3, 4. Time is moving, but the velocity y-axis value is not getting changed. So this is presenting the uniform velocity, and here slope will be equal to 0, right? So next is the velocity time graph, a straight line like this will be presenting the accelerating graph. Here acceleration A is equal to, you can take v2 minus v1 by t2 minus t1. That means the change in velocity with respect to change in time, right? So this straight line, the slope of this straight line presenting the acceleration. So acceleration is the slope of the VT graph. So here you can get the different VT data, like one, this is data point, this is one coordinate. Okay, you'll get the let's say this is x1 y1, this is x2 y2. Okay, now what will be the slope here? Slope m is equal to y2 minus y1 by x2 minus x1. This way you can calculate the slope, and this slope, this value is the acceleration. That's it. So this way, so this is an accelerating graph. Now again, if the graph, and what is the angle with the slope angle is theta. So this theta is the accurate angle. Now if I extend the graph like this, and if I draw a line, so this will be the retarding graph. This part will be the retardation, and this is the angle. The angle is from the x-axis in the anti-clockwise direction. This is theta. This theta is greater than 90 degree, greater than 90 degree. So this is the slope negative slope presenting the retarding motion. This way, you have to be the expert in the graphical part. Definitely you will get this kind of graph, right? Now, this straight line is presenting the uniform acceleration. If this is an any kind of, let's say, is a curve like this, VT graph is not straight line, then VT graph will be maybe in different, not like so this will be the non-uniform acceleration for the VT graph. Let's say like VT graph like this, if you get this kind of graph, that means initially this is an uniform acceleration, then this is the velocity is constant, again velocity increasing, so again this is a different acceleration part, again this is the the part of VT graph, velocity is not getting changing. So this way acceleration getting changing, so it's a kind of non-uniform acceleration, you can say. So you can get the graph like this. Okay. So this part accelerating, this part velocity time graph straight line parallel to the t-axis means uniform velocity, velocity is not getting change in this part again accelerating, this part again the VT graph not getting, velocity is not getting change, right? Now next is what is the area contain the VT graph. If this is an VT graph, so this area will be the the displacement, as you know that S is equal to ut plus half h square. So VT graph area is presenting the displacement of the the particle object in motion. So same like, suppose if you get like graph like this, okay, let's say this is a straight line, then what will be the area? So this area you will calculate, and this will be the presenting the displacement of the VT graph. So during the calculation of area, you can take the help of geometry. This is a rectangle, right? And in this area part, velocity is not getting changed. Velocity is not getting changed. Okay. And this part accelerating motion, and this part, this is the retarding motion. So this graph is presenting. Let's say take real example of the railway train. So train starting from zero, initial velocity zero, train accelerating, take the maximum velocity V max, then with this maximum velocity the train traveled for this time, again Vmax, from Vmax it's starting retarding, so final velocity 0. Okay, right? So this is a very important pattern of graph. So acceleration, uniform velocity, then retardation. Here acceleration slope positive, here slope is 0, here slope is negative. Why this part slope 0? Because this line and this line, they have angle between these two line is 0 degree. So tan 0 degree is equal to 0. So these are the concept you have to be with you for being comfortable for class 9 revision, right? Okay, just follow my classes. I think velocity graph we covered, right? There are a few other graph like, let's say velocity time graph. This could be like this also. So this is V and this is T. When it is happening for free fall, like if you are throwing a ball, initial velocity is high, the velocity will be 0. Let's say you are throwing a ball like this from here, like this, final velocity 0, again it will come back. So when it is coming back, the directions is opposite, so graph velocity vector will be in the downward direction. So this is presenting the velocity time graph. When you are throwing a ball upward, it will go max height, velocity 0, it will come here, then again it will come in the this direction, because the velocity direction getting changed. It's a vector quantity. If the similar graph you are going for the speed time graph, the nature will be different. What will be the nature? If I am replacing v with the speed, then speed time graph will be like this. This will be like, here 0, then again increasing. Because speed is an, if I am taking here speed is an, scalar quantity. So it depends on the magnitude. So magnitude, the speed was high here. This is the starting point high. It will be 0 in top height, then again it is increasing. So this will be the speed time graph. So speed is a scalar quantity. Okay. This way you have to be champion in the graphical part. Next is the Newton's laws of motion. As you know that A proportional to rate of change of momentum is proportional to the force applied on it. This is the Newton's second law. From here we are getting F is equal to m into v minus u by t, right? So from here you are getting F is equal to ma, mass into acceleration. This is very important, right? F is equal to mass into acceleration. Now again, if you are asking that Newton's first law, derive the first law from second law. According to Newton's second law, net force F net is equal to mass into acceleration. So let's say net force on an object is 0. So mass into acceleration will be 0. So mass can't be 0 here because we are discussing about an object. So acceleration will be 0. Acceleration 0 means v minus u by t is equal to 0. So v is equal to u. So object is under uniform motion. Object is under uniform motion. So you may be asked for Newton's second law, Newton's first law from the second law. So Newton's second law is saying that change in momentum, rate of change of momentum is proportional to the force applied on the object, right? Now, if the net force acting on object is 0, then the acceleration will be 0. If acceleration will be 0, right, that means v minus u will be 0. The v minus u will be 0 is, that means, object is under uniform motion. That's Newton's first law. So this way you can derive mathematically Newton's first law from the second law, right? So this way you have to go for practice. Follow my session. In next class, I'll be coming with the chapter 1 on the simple pendulum part and the pressure part. Okay. Okay. Thanks for watching the session. Right. Thank you.